Hey, so today we're going to go ahead and look at naming molecules or molecular nomenclature. So remember, molecules are going to go ahead and be covalently bonded substances. So today we're really going to be looking at substances that contain two nonmetals. So two nonmetals is the distinguishing factor for molecules. So once again, molecules, right, are the smallest unit of a covalently bonded substance. This is going to be forming between two or more nonmetals. Now, generally speaking, today we're really going to be looking at binary molecules, which contain only two types of elements. So remember, molecules can absolutely contain more than just two types of nonmetals. But some examples of things that we're going to work on naming today would be CCl4, which is carbon tetrachloride, Ni3, which would be nitrogen triiodide, or P2O10, which would be diphosphorus decoxide. Now, for the rules for this, I think that naming molecules are fairly straightforward. The hardest part is recognizing that you have and are naming a molecule. But the rules are as follows. So first, you want to name the first element as is, the element that appears on the left of the formula. You only need to use a prefix if there is more than one of that element. You always name the second element with the IDE ending, and you always use a prefix indicating the amount. And the prefixes are here. I think that they are fairly intuitive or something that you probably remember from either geometry or your Gen Chem class. But one is mono, think like a monorail. Two is di, three is tri, think like the tricycle. Four is tetra, five is penta. A Pentagon, right, is the big US building over on the East Coast. Hexa, hepta, octa, nona, and deca. You should probably commit these 10 prefixes to memory. So let's go ahead and work on naming the following compounds using the rules we went ahead and just established. So first one up is Pi3. So we want to name the first element as is, and if there's more than one, we want to use a prefix. So it's just phosphorus. There's only one of them, so all we have to do is list phosphorus, phosphorus. And then it's I3, so there's three of them, so that's going to be tri, that's three, and iodide. Remember, we end the second one with the IDE ending, so phosphorus, triiodide. The next one is CBr4. So C is carbon, carbon. I asked myself, is there one of them? And hey, look at that, C, there is. B4, so the prefix for 4 is tetra, tetra. And Br is bromine, so I'm going to change the ending to ide. So carbon tetrabromide, bromide is the ending for that. Notice that I'm not asking this, but I should always consider, are these molecules? That's the first question I always ask myself, and I know that all of these here in this entire column are molecules because they are two or more non-metals. So SF6, this is going to be sulfur. Sulfur, there is just one of them. 6 is going to have the prefix hexa, hexa. And F is fluorine, so this is going to change to fluoride. So fluoride, sulfur hexafluoride. That is a fantastic compound. If you don't know what that is, I would recommend checking it out. N2O4. So here's where we kind of get into an interesting thing, mostly because there are more than one of the first element. There are two. So I have to use that prefix to identify how many of the first element I have. But I still name it as is. So this is going to be di, because there's two nitrogens, dinitrogen. Notice I don't change the suffix for the first one, dinitrogen, and there are 4 oxygens, so it's going to be tetra is the prefix. Now, as far as oxygen goes, because it starts with a vowel, rather than say tetraoxide, we can make our lives easier and say tetroxide, tetroxide. So dinitrogen tetroxide. And same thing with the second one here. I noticed that there are 2 fluorines. There are 2 fluorines. So I need to use the prefix di, but I'm going to name the first element as is. This is going to be difluorine, difluorine. And once again, I didn't change the ending. And I always use a prefix for the second element. So how many oxygens did I have? I had just one. So that's going to be mono. And just like above, instead of saying monoxide, I'm just going to say monoxide. So this is difluorine monoxide. Last but not least, ICl5. Notice that the I is by itself, there's only one of them, so I don't need a prefix for this. So it's going to be iodine, and there's 5 chlorines. So that's going to be penta, iodine, pentachloride. I really love the molecules because it's pretty much just using the IDE ending for the second element, and you always indicate the amount of the second element. You only have to indicate the amount for the first one if there are more than one. So with that being said, we want to be able to go the other way. We want to be able to write the formula given the name. So writing molecular formulas requires us to still know the prefixes. But what's really nice is when you say the name, it pretty much just tells you the number and type of elements that are there. So what I mean by this is the molecules are the only substances that are named with prefixes. And the prefixes, once again, mono, di, tri, so only for molecules. And the prefixes indicate the amounts of the elements. It's really straightforward. It's it's a nice system that we have. So oxygen dichloride, we know that there's going to be 1 oxygen. We know there's going to be 1 oxygen. And di is 2, so it's going to be OCl2. Nitrogen trichloride, so I didn't use a prefix for the first one, so it's going to be 1 nitrogen, and tri is 3, so it's NCl3. Silicon dioxide, silicon is Si, and di is 2, so SiO2. The prefixes always indicate the amount for the second one, and then the element is always going to end with the IDE for the second one. Awesome. Thank you so much. And as always, if you guys have any questions, feel free to shoot me an email. Thanks a lot.